In this video, we're going to do a couple of examples using the quotient rule. So that means we have a quotient that can't be simplified into anything nicer. So r prime of z is going to be the denominator. So z to the fourth plus 1 times the derivative with respect to z of the numerator, so 3 raised to the z power, minus, so this time the order does matter. It doesn't in the product rule. Quotient rule it does. Now the 3 to the z gets left alone times the derivative of the denominator, z to the fourth plus 1. As you get more practice with the quotient and product rules, you won't be needing this notation as much as what you'll find. Over z to the fourth plus 1, that quantity squared. Also, a lot of times with the quotient rule, there's not a lot of simplifying we can do. But let's see what happens. So first off, this was held constant, z to the fourth plus 1. And then the derivative of an exponential has itself, so 3 to the z times natural log of the base, minus 3 to the z times the derivative of that guy there, which is 4 z cubed, all over z to the fourth plus 1 squared. Now we could factor out a 3 to the z out of the numerator, but that would be as far as we can go, and it's not going to help us simplify this much more, so I'm just going to leave it there for now. The biggest thing is the structure of the quotient rule takes a little bit of getting used to. So let's try this second one, v of t, and I'm not going to use the dt notion this time. We're going to do it all at once. So v prime of t is the denominator, so cosine of t plus t squared times the derivative of the numerator. Derivative of sine is cosine, minus, now we'll leave the numerator alone, sine of t times the derivative of the denominator. Derivative of cosine is a negative sine of t plus the derivative of t squared is 2t, all over the denominator squared. Cosine of t plus t squared squared. There's really nothing we can do to simplify this much further. We could distribute the cosine and see what's going to happen. Let's go ahead and do that, because sometimes some interesting things can happen. So, distributing that cosine, we get a cosine squared t plus t squared cosine of t. Here's where things will get a little interesting. Minus sine of t and minus sine of t is a plus sine squared t. And then finally, minus 2t sine of t, all over cosine of t plus t squared squared. Notice what we have here. We have a cosine squared plus a sine squared. That's our Pythagorean identity, so it's actually equal to 1. So we can come down to the next line. That's going to be equal to 1. And so what we're going to have is a t squared cosine of t minus 2t sine of t plus 1 in the numerator over cosine of t plus t squared squared. So we were able to get this thing a little bit nicer looking. There's a little bit less going on if we had to take another derivative or work with it.